So looking at 2, we're solving the equation. It says check your solution. Always, 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 when you have fractions, when you have x in the denominator of your fractions, you want to check your solution. On the quiz, it's not going to tell you to check your solution. You just always have to know. Here, x cannot be what two numbers? 0 and what else? And -8. So right off the bat, we know that 0 cannot be an answer, -8 cannot be an answer. If this was an inequality and our answer was a interval notation, we'd have to make sure that our interval notation does not include 0 and it does not include -8. So let's solve. For here, we want to multiply by our least common denominator. What would our least common denominator be? X plus 8 is in our least common denominator. What else? X. So everything's going to get multiplied times x and x plus 8. X and x plus 8. X and x plus 8. But if it's already in the denominator, we can just cancel it out. So in my first one, I have 40 times x plus 8. Then x plus 8's cancel in my next fraction, so this would be minus 5x is equal to, here, x squared plus 8x is x times x plus 8, so it cancels out. So then on top, we just have 8 times x plus 13. So sometimes you may have to factor one of your denominators to see what your factors are, to see what belongs in the least common denominator. From here, we can just solve. I distribute, so 40x plus 40 times 8 would be 320, minus 5x is equal to 8x plus 8 times 13. Would be 104. Combine like terms. So I'm going to subtract the 320 to move it to the other side. And subtract the 8x. So we get 27x is equal to 104 minus 320, which would be 216. Negative 216. Divide both sides by 27. We get x is equal to, pretty sure, -8. You won't get any calculators for the quiz tomorrow, but everything is small numbers. It's all doable without a calculator, smaller than this. Can -8 be a solution? No. So what would our answer be? No solution. So if we got -8, we'd want to check our work, and you can plug it back in, and we'd see that we get 0 in the denominator. So for 5, we're solving the quadratic equation by completing the square. So here, since I start with a coefficient, leading coefficient that's not 1, I want to get rid of that 2. So I'm going to divide everything by 2. So we always want to start with the leading coefficient that's 1 when completing the square. So we get x squared plus 5 over 2x. I'm going to move my constant to the other side. So I'm going to do 2 steps in 1 here. So this is equal to 21 over 2. And I'm going to leave a space here to complete the square. What's the little formula that we use to complete the square?
B over 2 squared.
B over 2 squared. So we have 5 over 2 squared. Well, when we have a fraction and a fraction, so 5 over 2, we keep change flip. So multiply by 1/2, we get 5 over 4. So I'm just going to rewrite that to make it a little bit nicer for us. This turns into 5 over 4. Now we have to make sure we keep our equation balanced. I just put this 5 over 4 squared out of nowhere. I plugged it into the left side of my equation, so I also have to remember to add it to the right side too. So 5 over 4 squared would be 25 over 16. So I'm going to add 25 over 16 to the right side. Now in my parentheses squared, I'm going to put my x and 5 over 4. So x plus 5 over 4 squared. And that would be equal to, on the right side here, we got to add, so we need a common denominator. I'm going to multiply the top and the bottom here by 8. So we get 168 over 16. When we add these, we get 193. So 193 over 16. Now from here we can solve. What would we do to solve? Square root both sides. We want to get rid of that squared, so we're going to square root both sides. So x plus 5 over 4 is equal to what?
193 over 4.
What are we missing?
A plus or minus.
Plus or minus square root 193 over 4. Awesome. And then last up, we're going to add or subtract the 5 over 4 to move it to the other side. So x is equal to negative 5 over 4 plus or minus square root 193 over 4. Webassign, you have to put them in as two separate numbers. So notice how here it gives us the answers. So one of them is negative 5 over 4 minus square root 193 over 4. The other one's plus, but on a test or quiz, you can leave it as plus or minus. But if you wanted to write it together, you could too. So negative 5 plus or minus square root 193 over 4. If you wanted to give them all the same denominator. Either way is fine. But on test or quiz, you can leave it as plus or minus. So number 8 says find the solutions. What would we do to solve here?
Can you take, I think it's like 5x and then the x minus 8.
Awesome. We want to take out our GCF, so we're going to take out a 5x. Perfect, because that's our GCF from the coefficients of our parentheses here. So 5x, and then you said x minus 8 to the what power? What would we take out? What's our smallest 1/3? So when we take this out, we're left with 2x. When we divide out that x minus 8 to the 1/3, it cancels out with that first one. So plus 5x divided by 15x divided by 5x would be 3. And then x minus 8 to the 4/3 divided by x minus 8 to the 1/3. What do I do to the exponents? For taking out the x minus 8 to the 1/3, how do we find out how much we have left? What do we do to the exponents? Awesome, subtract. So 4/3 minus 1/3 would be 3/3, which is 1. So this would be x minus 8. We can simplify in our brackets here. So 2x plus 3x minus 24 would be 5x minus 24. And then we have 5x and x minus 8 to the 1/3 on the outside. What can we do next? What should we do next? From
Make it cubed or no?
No, from here, since it's all of our factors of it, we just set them all equal to 0. So 5x equals 0, x minus 8 to the 1/3 equals 0, and 5x minus 24 equals 0. So x is equal to 0. For the next one, x minus 8 to the 1/3, how would we solve? How would we get rid of that 1/3 power? Cube it. And what's 0 cubed? Still just 0, so it goes away. So we just have x minus 8 is equal to 0, so x is equal to 8. And then same thing with the last one, we're going to add 24 to both sides and divide by 5, so x is equal to 24 over 5. So these would be our 3 answers. So 9, we have an absolute value. We always want to isolate our absolute value first, and then to get rid of our absolute values after we isolate, we need to split it into 2 equations. So we have 11x plus 3 is equal to 8. So the first one stays the same. The other one we change to negative. So 11x plus 3 is equal to negative 8. And then we just solve both of our equations. Subtract 3 on both sides, so 11x is equal to 5. Divide by 11. Thank you. And then same on the other. Subtract 3. 11x is equal to negative 11. Divide by 11. X is equal to negative 1. With absolute values, I would always check, but you really only have to if you have an x on the outside, but there is no harm in always checking, just to make sure. Next, let's do 11. We want to solve the inequality and graph. So when we have an inequality, so greater than, less than, we want to get it to just be one fraction on one side, so then we can set the numerator equal to 0, the denominator not equal to 0, and find our key values, and then find the intervals of where it works. So here, I want to combine these together. So what do I need if I'm adding or subtracting fractions? Common denominator. So I'm going to make it 3 over 1 and multiply the top and the bottom by x plus 1. So we get x plus 9 minus 3 times x plus 1 on top and x plus 1 on the bottom. It's less than 0. Distribute. So x plus 9 minus 3x minus 3. This would be negative 2x plus 6. Over x plus 1. It's less than 0. So to find our key numbers, we set the numerator equal to 0, the denominator not equal to 0. So negative 2x plus 6 equals 0. We get x is equal to 3. And then x plus 1 does not equal 0. X does not equal negative 1. We're going to put those on our number line. So negative 1 is going to go first, and then 3. Since negative 1 is not included, we can't have negative 1 in our domain. It gets an open circle. Now for x equals 3, what do you think, open or closed circle? It's open because it's just a less than sign. If this was less than or equal to, it'd be a closed circle. So we always look at the inequality for the one where we set our numerator either equal to 0. So it's either going to be an open or closed circle. It could be one or the other. Look at the inequality to tell you. So 3 is an open circle also. So we want to check our intervals. I'll call it 1, 2, and 3. So for our first interval, what's a number that's less than -1? -2. So I'm going to plug in -2 and see if that satisfies my inequality, see if that's a solution set. So when we plug in -2, I'm going to plug it into my equation here. I like using the simplified one, but you can use the original equation that we started with also. So we have -2 times -2 plus 6 over -2 plus 1. This would be 10 over -1, which would be -10. Is -10 less than 0? Yeah, so it works. So that's going to be part of our domain. Next, let's test our second interval set. So what's a number in between -1 and 3? 0. So let's plug in 0. So when we plug in 0, we get 6 over 1 is less than 0. So 6 is less than 0. Is this true? No, 6 is not less than 0. So the second set does not work. Let's test the third. What's a number greater than 3? 4. So x is equal to 4. So when we plug in 4, we get -8 plus 6 over 5. So this would be -2 over 5. Is that less than 0? Yep, a negative number would be less than 0. So that works. So our answer would be from -infinity to -1 with a parentheses because it's an open circle, and then a union, and then from 3 to infinity, and 3 is an open circle also. So that would get a parentheses. We want to find the domain. What do we do to find the domain when we have a square root? What can we not have under a square root? What would we do?
Negative.
Can't have a negative under the square root, so we have to say whatever's under our square root is greater than or equal to 0. So we set everything under our square root greater than or equal to 0. So x squared minus 25 is greater than or equal to 0. Couple different ways we can solve here. We could move the 25 to the other side and square root both sides, or we could just factor. So when we factor, we get x plus 5 times x minus 5 is greater than or equal to 0. So x would be equal to -5 and +5. So for here, we got to test our answers. So whenever you have a polynomial in your inequality and you end up with more than one answer, you want to test which interval it works in. So we have -5 and 5. Are -5 and 5 going to have open circles or closed circles? Closed circles because it is a greater than or equal to. That equal to makes them closed circles. So we've got interval 1, interval 2, and interval 3. What's a number that is less than -5? -6. So when we test for interval 1, I'm going to say x is equal to -6. When we plug it in, we get 36 minus 25, which would be 11, is greater than or equal to 0. Is this true? Yep. So it works in 1. Let's test 2. What's number in between -5 and 5? 0. So let's plug in 0. We get -25 is greater than or equal to 0. Is this true? Nope. So it does not work in the second. And then let's test the third. What's number greater than 5? 6. So 36 minus 25 would be 11 is greater than or equal to 0. Is this true? Yes. So it works in the third interval. So we would say from negative infinity to negative 5 with a bracket and a union, and then bracket 5 to infinity. So it helps to label the points. I'm going to call it x1, y1, x2, y2, and plug them in. So for our midpoint, we have negative 4 over 5 plus negative 1/4 over 2. And then our y is negative 1 over 5 plus negative 5 over 8 over 2. What do we need if we're adding with fractions? Common denominator. So the first one, our common denominator would be 20. So I'm going to multiply the top and the bottom here by 4. So I have negative 16 over 20. And the second one, I'm going to multiply the top and the bottom by 5. So it'd be negative 5 over 20. So when we add those together, we get negative 21 over 20 over 2. What do we do if we have a fraction in a fraction? Keep, change, flip. Keep the top. Change to multiplication. We're going to flip the bottom. So 2 on the bottom is like 2 over 1. So when we flip it, it becomes 1/2. When we multiply fractions, we multiply straight across. So it'd be negative 21 over 40. So that would be our x for our midpoint. We're going to do the same thing to find the y. So here our common denominator would be 40. So I'm going to multiply the top and the bottom of my first fraction by 8. So we get negative 8 over 40. Second fraction, I'm going to multiply the top and the bottom by 5. So negative 25 over 40. So negative 8 minus 25 would be negative 33 over 40 over 2. Same thing, we're going to keep, change, flip. So keep the top, change to multiplication, and flip the bottom to 1/2. Multiply straight across. So we get negative 33 over 80. So this would be our midpoint. Bless you. I'm going to do another midpoint question. So let's say the question gives us the midpoint. So it's the midpoint is, we'll say 4,6. And it gives us the end point of 8, negative 3. And it says find the other endpoint. What would we do here? Bella.
Find the distance.
You could find the distance. That would work, but it also, you would need to know like the direction of where to go to. So that would be, because if these are not the right points, but let's say our end point was here and our midpoint was here. We could find the distance, but then we'd also have to apply that distance to here to find the other point. So it'd be more work than what we need. Any other ideas? Kylie.
Can't you just find like the difference between the x and the difference between the y and then either add or subtract it to them?
We can do that. Yes. I'm going to do it algebraically. So just plug it into the formula, but it's the same idea of what you said. So we're going to find the distance from how far our end point is to the midpoint and then just go in that same direction to find the other end point. But I'm going to plug it into our formula. So our midpoint formula was x1 plus x2 over 2 and y1 plus y2 over 2. So our end point, I'll call it the x1 and y1, and our midpoint is going to be what goes on the left side of our equation. We're plugging that into our midpoint. So our x values for our midpoint would be 4. So 4 is equal to x1 we said was 8 plus x2 over 2. So I just plugged it into the formula. Our formula gives us the midpoint, but we started with the midpoint, so we're going to plug that in and find our x2. I'll solve this one out, and then we'll find the y's next. So to solve for x, we want to multiply both sides by 2. So we get 8 is equal to 8 plus x2. We're solving for x2, so we subtract 8 on both sides, so 0 is equal to x2. So in our endpoint, the x is 0. Let's do the same thing for the y's. So our y in our midpoint is 6. So 6 is going to be equal to our midpoint formula for the y. So y1, we said, is -3 plus y2 over 2. Solve it the same way, so we're going to multiply both sides by 2. So 12 is equal to -3 plus y2. Add 3. So we get 15 is equal to y2. So that would be our answer. This is our other endpoint. Any questions here? So another way we can think about it is from our endpoint, so from 8 to 4, we're subtracting 4, so you can subtract another 4. So 4 minus 4 would be 0 to get our other endpoint. From -3 to 6, we're going up 9. So if we add another 9, we'd get 15. So you can think about it that way, but it does get a little bit more tricky to do it that way if you have fractions. But that totally works. It's a lot less work, but same idea.